Right, so this is my topology. So this one is pretty small one. So I'm just it's for the lab, so that's why I did not configure anything much here. So now on this network over here, so I would just make the topology itself. On this network over here, this will be the inside network with 10.1.1.0/24 network. And on this side, it will be the inside network with 12.1.1.0/24 network. Over here, this one is 192.168.1.0/24 network. And over here, it is 192.168.2.0/24 network. And the interfaces are .1 and .1 on the inside also, and .1 on this side, and .1 on this side. I have connected the management, but I have not configured anything yet. So to change that one to, so that is my management network for now. Next, for the ISP, both the interfaces it's been configured with .254. So pretty much all the topology is ready except the ASA. So if I go to my ISP, you see that I have configured these two interfaces. And if I say that show IP route, there is no route over here. So it just ISP only has the knowledge about this network, and this network, it doesn't have knowledge about any other network. So if I go to my server, that should be show interface IP brief or show IP interface brief. And you see that I have assigned the IP address. And if I say that show IP route, there is a default route going towards my ASA. Coming to the R1 also is the same thing. Do show IP interface brief and do show IP route. There is a default route going towards that one. So I also have the PC. So I'm going to ping, and as well as I will going to take the TCP connection. So let's get to the ASA one now. So I will go ahead and do that site to site VPN. So basically what's going to happen is that I'm going to do the IKE version 1. Right? So you have to be clear over here. What do you mean by the VPN now? So VPN is the virtual private network. And there are different kinds of VPNs which you have to be careful. Now, normal VPN is like you just create a tunnel, and over that tunnel, you will just go and communicate with that one. That's the normal VPN. But again, we are talking about the VPN with the encryption. So this is the important part over here where on the normal VPN, you do not get that one. So what we get, the VPN which are cheaper online and everything, those are not encrypted ones. So because the encryption is a little bit expensive. So the normal VPN is like just to create a tunnel between those two networks, those two peers, and after that, on top of that tunnel, you will just go ahead and communicate. But when you do a packet tracer on this particular link, it will show you that internal network also. It will expose that internal network also. Now, the concept of encryption here is that we are going to create two tunnels. So one tunnel will be used to exchange the keys. That will be our IKE version 1 keys. Another tunnel will be for the data. So there will be two tunnels created, one for the keys exchange and another one for the data exchange. So we are going to encrypt that traffic, and that encryption will take place with the ESP protocol. So ESP protocol, so whenever the packet goes from this side, so the packet will be received by ASA. After receiving the ASA will encapsulate into the ESP header, ESP protocol. So basically the header looks like 192.168.1.1, that is the source, which is the ASA1, and 192.168.2.1, which is the destination ASA2, but the inner header, that will be the ESP protocol. And after that, there will be another header that will be 10.1.1. maybe 2 source, and destination will be 12.1.1.2, which is the server 2. So this is how your packet looks like now. And after that, you will have your payload. So this packet is visible on the internet, but this packet is encrypted. You can see it's running an ESP protocol, but this whole thing is encrypted. No one is able to see that one. So actually you're communicating your inside network to the inside network of your different branch or a different site, destination site, but you're only going to see that public IP address, but you're not able to see that payload or the inner header of the ESP. So now I think ESP will be running on port number UDP 500. And if it is behind the NAT, if I have a router and then when I am going to create configure the site-to-site VPN, which is behind the NAT, then the port number, I think it should be 4500. All right, so that will be our site-to-site VPN. So let's go ahead and configure. So currently you see that I have configured, given the IP address, this one is configured. All of these are configured except my ASAs. So the only thing I have to do is that I need to configure the ASAs. So let's go ahead and configure that one now. Now for the ASAs, first I will do the basic configuration. That should be host name will be ASA1V and interface gig 0/0, name if will be outside and IP address will be 192.168.1.1. Interface gig 0/1, name if will be inside, IP address will be 10.1.1 and no shut exit. And I will say that route outside default 192.168.1.254 and save it. And I will do the same thing for the ASA2 now. Config the interface. First, I will do the host name ASA v2 interface gig 0/0. Name if will be outside. IP address will be 192.168.2.1, 255.255.0. No shut interface gig 0/1. Name if will be inside. IP address will be 12.1.1.1. And no shut exit, and I will say that route outside 00192.168.2.254 and save it. And if I say that ping 192.168.1.1, it's pinging. And if I say that ping 12.1.1.2, it's pinging. So all good now. Now I am ready to configure my IKE version 1, that is IKEV, that is Internet full form, I think it is Internet Key Exchange version 1. IKE version 1 is Internet Key Exchange version 1. So let's go ahead and do that one. So first, what I'm going to do that in this step now, the first step, I will going to configure the haggle now. So what do you mean by haggle? HAGLE, haggle. So H stands for hash, A stand for authentication, G stand for group, Duffelham group, and LE stands for, I think, encryption. Well, E stands for encryption. I'm not sure what do we mean by L. Okay, life. L is the lifetime. So lifetime means you're defining that tunnel where the keys will be exchanged. You're defining the number one tunnel to be like after 1 hour they should tear down, and after 1 hour they should recommunicate. It's like I created the first tunnel, the keys have been exchanged, and I want after 1 hour it should be teared down. After tearing down, it should recommunicate, and they should form another tunnel after 1 hour. So this will be defined only because of the what do we say? Just to make sure that you are much secure. So that's the reason you define the lifetime. Otherwise, you can skip this option. That should be fine. Because by default, there is something value known as 86,400 something. We will look into that one. So first we have to configure these things now. So these things will be used to create the tunnel, first tunnel. So if my first tunnel is up, then only my second tunnel, the data tunnel, will be up and running. So data will be communicated, otherwise no. So first I have to configure this one. So let's go ahead and do the config now. Now to configure the haggle now, so how you can configure is that I will go to ASA1 and I will say that crypto IKE version 1 policy number, just any number. It's not 10, it can be any number. I'm saying that I want to do the authentication, but it should be a pre-share, means I am using a keyword like a password for authentication. I'm saying that encryption, and you see that you can select anyone. So I will select 3DES, and I'm selecting that hash. Hash also you can select MD5 or SHA. MD5, both of them are secure. And the group, and if you see that group will be 1, 2, 5, and 7, you can select anyone. So now group is like the length of the key. So for group 1 means it will be 512 MB. Group 2 means 700 and something MB. Group 5 means I think 1024 MB. So length of the key, that the more the length of the key, it's harder to break that encryption. So now lifetime, and you see that by default you can give this number, but by default I think it is 86,000 something. So I will say that I want 1 hour, 3600 seconds, and exit. That's it. So next, what I have to say is that I need to enable the IKE version 1 on which interface. So currently it should be on the outside interface. So I will say that crypto IKE version 1 enable outside. Next, when I go to the peer, what should be my identity? So I want my ASA to use any identity, that is crypto ASA camp identity address. So basically it will use the outside interface IP address. Next, I want to define the characteristics of the tunnel. So first I will say that tunnel group 192.168.2.1, because I want to create a tunnel with the peer ASA2, that is 192.168.2.1. And I'm saying that the type of the tunnel will be site to site, L2L, IPsec L2L. So let me see what are the different types too. Now, so it is only one IPsec L2L, but basically I have given, so that's why it's giving me address. So what I am saying that I want to create a tunnel that will be point-to-point tunnel. That's what I am saying. Encrypted IPsec, that means encrypted, but L2L means point-to-point. Now, once I define the tunnel, I want that tunnel group 192.168.2.1, and I want the IPsec attributes. I want to define the characteristics of that tunnel now. I don't want to do anything. I just will say that IKE version 1 pre-shared key will be Cisco. But if you like, you can define these many things. So exit. I'm just saying that the characteristics of the tunnel will be pre-shared key, that is the password. So if you see that password is matching, establish the tunnel. That's it, nothing else. Next is that my access list. So I want to define the interesting traffic with respect to the ASA1 10.1.1.0/24. That is my network, which is the source, and the destination is 12.1.1.0. So that's what I have to define. So I will say that access list VPN, and I will say extended permit IP. Again, if you permit only TCP connections will be made. If you permit IP, that means ping, TCP, everything will be allowed. So permit IP, source will be 10.1.1.0, 255.255.0. Destination will be 12.1.1.0, 255.255.0. My access list has been created. Now, all the pieces are in place. Let's go ahead and assign one by one. Now, crypto map CMAP number 10. Match crypto map CMAP number 10. Match address VPN. So what I am saying to my crypto map is that I'm just assigning a sequence number 10, and I'm saying that match the address which is on my access list VPN. So if you see any traffic which is matches to the access list VPN, match that one. After matching, crypto map CMAP number 10, set peer 192.168.2.1. Make sure that you form a data tunnel with the 192.168.2.1 ASA2, and crypto map CMAP number 10, set IKE version 1 transform set as T set. So now he says that I did not create any transform set. So let's create crypto IKE version 1. That should be IPsec IKE version 1, transform set T set ESP, AES, ESP, SHA, HMAC. So what I'm saying is that I want to do the encryption, that is IPsec. So encrypt using AES protocol or ESP protocol, using ESP protocol, AES encryption, and the data will be encrypted using the SHA hash. So let's go ahead and say now crypto map CMAP number 10, IKE version 1, transform set to T set. Now it can be any name. I'm just selecting the easy name as T set. It can be any name. Next, once all the things have been defined, now let's go ahead and apply it. So I will say that crypto map CMAP, that should be applied on the outside interface. So show run crypto. Now what I did was, first I have created the first tunnel negotiation details, that is the crypto IKE version 1 policy number 10. I want to do a authentication using a pre-share. That means I'm looking for the password. Encryption, I'm using 3DES. Hash will be the SHA, group will be number 2. And after that, I made myself identify any address, that is the outside interface, and I have enabled the IKE version 1 on the outside. Next thing is that I set to my crypto map that match the traffic which is on the access list. Whenever you match the traffic, send that traffic to the destination, that is 192.168.2.1, encrypt it using the transform set as T set, and it should be applied on the outside. That's it. Let's go ahead and do the same thing on the ASA 2 now. So I would say that crypto IKE version policy number 10. I will say that authentication will be pre-share, encryption will be 3DES, and hash will be SHA, group will be 2, and lifetime will be 3600, and exit crypto IKE version 1, enable outside. It can be anytime you can give it, not a problem. Crypto IKE ISACAMP identity address, and I am saying that tunnel group 192.168.1.1. Type will be IPsec L2L. And after that, again, for that tunnel group, I'm defining the characteristics, that is IPsec attributes, and I'm just looking for pre-shade key, that is Cisco, and exit. Next will be the access list. So let's create that one, or before that one, I will say that crypto IPsec transform IKE version 1, transform set T set ESP, AES, ESP, SHA, HMAC, and access list VPN extended permit IP. This time it will be reverse 12.1.1.0, and the destination will be 10.1.1.0. And crypto map CMAP number 10, match address on the VPN. Crypto map CMAP number 10, set peer as 192.168.1.1, and crypto map CMAP number 10, set IKE version 1 transform set to T set, and crypto map CMAP number 10. Now it's interface outside. That's it. So once this is been done, let's go to the R1 now. And if I say that do ping 12.1.1.2, I'm able to ping. If I go to my ISP, and if I say that do show IP route once again, right? So my ISP has no knowledge about it, but my R1 is able to ping. So if I want to check, I will say that show crypto IKE version 1 SA, and you see that the tunnel is up and it is active. Since the traffic initiated from the ASA 1, so it became the initiator. And if I go to ASA 2, if I say that crypto IKE version 1, and you see that he is the responder because ASA 2 has responded. So what I will just go ahead on here and start a packet capture. Again, I will initiate the TCP connection over here now. All right, so this is my PC now. I will say that 12.1.1.2. I should have the access, and that's it. I'm saying that show IP HTTP server history. And now you see that I'm able to access, and I will stop that capture. And you see that over here, all the packets are ESP packets, ESP protocol, and it has been encrypted. So what I'm going to do, I'm going to select any random packet. And over here, you see that internet name, nothing. And if I go to Ethernet to destination and source MAC address, so I will verify the source MAC address on the ASA. So if I go to ASA1 now, source, so run interface gig 0/0 or show interface gig 0/0. The MAC address was yeah, it should be matching. So AABBCC 00000210. Okay, here it shows different. Let me check the destination one. Show interface gig 0/0. Okay, destination is matching 0CD7 0000000 and 0001. But I'm not sure why the source is not matching. Let me see the latest packet. That is the last one. And on the last one, yeah, everywhere is the AABBCC. Not sure why. Show interface gig 0/0. So it should match this MAC address, but I'm not sure why for some reason it is not matching. But on the ASA2 it is matching, so that's fine. Now you see that the source and the destination is only the outside interfaces I'm able to see on the internet. And if I scroll down more, internet protocol version, I don't see any flag, I don't see anything. You see that source address and the destination address I'm able to see, but once I see the payload is totally encrypted. You see no information about the payload, what's happening with the payload. All right, so that was your site-to-site VPN. In other way to verify that one is that if I go to show crypto IPsec, that is another command to verify. And over here, you will see that the packets have been encrypted and decrypted. All right, so here you will see that who is encrypting and who is decrypting, for which traffic you are encrypting. So if I go back to the ASA2, if I say show crypto IPsec, and here also I should see that the encrypted traffic and the decrypted traffic and the access list. And if I say that show access list, and I see that it is been hitting over here. And if I say that show access list, you see that it is been hitting over here. So with the CLI, it works perfectly fine, but with I do not recommend the ASDM. But anyhow, we have done the site-to-site VPN with ASA with IKE version 1. I hope this was informative for you, and